Yeah, so welcome to the design for 3D printing and material selections, and let's let's give another minute to wait for other people to join in. So one thing is that I do ask if you guys can mute so that we don't have any background static going on. And other stuff is since I think I don't have the participant list for this skill sessions, but what I'm gonna do for the beginning of 10 minutes, we'll quickly go over like introductions, like what's your major and then what's your interest and what do you want to take out from 3D printing or material selections. This class, I guess this content I'm covering can be a very extensive or be very specific. So I sort of want to have an idea like, okay, what kind of stuff you want to get out of this in this like 60 minutes of lecture. So that's one thing we're gonna do. So what I'm gonna do right now, I'm just gonna pull up my slides and then wait for another minute. So yeah, okay. So how about let's do it like this. If you can, I mean, if your video is like if your camera is working, you can if you can turn it on. I mean, if you it's not working, it's fine. But I guess I just want to make sure that you're actually there, and I want to double check, and then I'll basically first go through the introduction. So, by the way, my name is Tim. I'm a PhD student in material science. I am currently a TA with the EPICS. Originally, I was the TA for MSE Bronze, AT, Call team, and the Vets team. Currently right now I'm transferred into lab TA. So sometimes like if you're in the class, you might see me like walking around in the corridors or in the classrooms. Basically, I'm just double checking the hygienes and all the facilities working in the EPICS facility. So yeah, so if in the future for this semester or the future semesters, if you have anything you want to kind of get access to or you want to, get into how to use it, make sure you can contact me and I'll make sure you get the rightful resource for doing that. Okay. Um, yeah, so let's quickly go over like briefly like who you are, what's your major, and then what's your team currently, like what team are you in, and then what would you like from, what would you want to learn or like get from the 3D printing and the material selections. Okay, so how about let's go from Fan Jeffrey. Are you there?
Yeah, I'm here. Can you guys
All
hear
right.
me?
Yeah, perfect. The thing
Okay.
is, everybody has their camera turned on, so actually it's really hard to see who is who right now, but I guess I can see your name. All right, go ahead. All right, great. Thank you. I see you now.
Okay. My major is biomedical engineering, and I'm on the Wabash Center, and I made 3D parts for my team last semester, and I want to learn more about selecting the right material or a better material for my purposes.
All right. All right. That sounds actually what I'm gonna teach for today. So okay, that's very lucky. All right. Thank you. All right. Let's move forward. Hannah. All right, you're on my list for the second one, so are you there?
Okay, can you hear?
Oh, yeah,
Yep.
perfectly. Okay. So I just want to make sure you're
Okay,
there and
cool.
then not your here.
Yeah, so my name's Hannah. I am a senior in computer engineering, and my main goal, like to get takeaway from this presentation, so like I have 3D printing experience, but it's mostly trial and error. So having like a more solid foundation to draw on when I'm actually like, choosing materials, designing my 3D prints is going to be helpful just to make sure that the parts I design are good.
Yeah, that's actually a good point. Yeah, yeah. Thank you, Anna.
Yeah.
So yeah, Hannah mentioned a good point is that a lot of people, I guess, in terms of 3D printing in the current status in the EPICS room right now, we only print POA, but it's really not limited to POA. And by the way, I will talk about what POA it is, but it's only the material you can select. It's not like you can choose ABS, nylon, or print metals. So it's pretty by definition, it's pretty limited by itself, but for in terms of 3D printing, there's actually a wide sort of a scope you can, kind of choose on. Now, I don't want anybody that to be angry. The thing is that you when you enroll in this class, you have a high expectation to learn all the 3D printing in 50 minutes. And that's actually, I wish I could, I wish I can, but it's really not. So after this class, if you feel you still feel kind of, depressed about not learning all what the questions you're being answered, please contact me anytime, and I'm willing to spend 5 hours, 10 hours to teach you about 3D printing. That's what I'm here for. So all right, let's move on. Julia, all right, are you over there? It's really hard to see. Julia, hello.
Hello.
Hey.
Can you hear me?
Yeah.
Okay.
Perfect.
Yeah. So I am a junior in electrical engineering, and I'm in Deaf Kids Code. So last semester there was a person who knew a lot about 3D printing and like all the materials and everything, and I just didn't know anything. And so now that he's gone and I'm the design lead, I kind of just want to know more so that we can continue continue with 3D printing.
Okay. Yeah. Okay. Thank you. Next one. All right. Help me out with this pronunciation. Kyaw, Kyaw. I'm sorry, if I didn't pronounce your.
That would mean it's Joan.
Joan. Okay, great. Hello.
Hi. So I'm a senior in civil engineering. So currently my team is working with City of West Lafayette to build a bike repair station. Hopefully, I'm not sure yet if we have a need for choosing a material, or if we did need a 3D printing, then I'll be ready for it. So I'm just here for that.
Yeah. So correct me if I'm wrong. You did mention that you want to 3D print a bicycle or something, or like
bike repair station. So
okay.
It's mainly for educational purpose for the children.
Okay, so have you determined what kind of material you're gonna choose to release? Build that?
We're still in the brainstorming stage. The project just got started this semester.
Oh, okay. So that's okay. So you probably still have some time to kind of brainstorming which material to choose. All right, great. All right, thank you. Let's move on to. All right, guys, help me out with the name. Mridula. I don't want to pronounce it incorrectly.
Hi.
Hello. So how do I pronounce your name?
It's just Radula.
Okay, Ruda. Okay. Hello. All
Hi.
right.
So I'm a junior in electrical engineering, and I am on the zoo team. More specifically, the butterfly box, which is supposed to be a box that collects donations, and then when a donation is put in, it lights up and gives a butterfly fact. So I want the last EPICS team I was on, we did some 3D printing, but there was someone who knew how to do a lot of it, so I wasn't very involved in it. And this semester, it looks like we're going to be doing a lot more printing for a new prototype, or at least parts of it. So.
Yeah, so I see a lot of your teams actually had a lot of woodcraft in the back of the first floor of the EPICS room, like these gigantic, like a wood tablet, and then you can press button. Yeah. So I guess I'm quite surprised for the team that you're in right now. They actually also consider 3D printing as is this a proof of concept, like a prototype, or something once you print it out, you're gonna put it in the zoo or something?
So I mean, so it's like you were saying, like the wood, it actually got sent back because it wasn't very weather resistant. So it was struggling, and so they sent it back, and now we want to make an actual one made out of more durable plastic, so it can last longer.
Oh, so you're considering like 3D printing as like the final, items, and then okay, so this is actually this is a great thing you're considering, and then like later on throughout like the semesters, and then we can talk more to how you're gonna do 3D printing. So actually, all right, good, all right, thank you. Let's yeah, thank you. Move on to Nathan. Hey, Nathan.
Hello, can you hear me?
Yes.
All right. So I'm a junior in Triple E, and I'm on Team India, more specifically the Mobile Science Lab. We haven't really talked about 3D printing all that much. We've kind of thrown around the idea just a little bit. But I'm here more so just for my own knowledge. I know absolutely nothing about 3D printing, and was hoping to get a little basis on it.
Okay. So when you say that you're triple E, it's environmental ecological engineering, right?
Yes.
Okay, got it. All right. Okay, thank you, Nathan.
Thank you.
Next one, Rico. Did I pronounce that name correct?
Yes, it's Rashio.
Rashio. All right.
Yeah.
Thank you, Rashio. Yeah.
So I'm a sophomore in aerospace engineering, and I'm on the Imagination Station team. And I'm here because we might have to 3D print some small parts in the future, and I kind of want to know what materials that I should use for those parts later this semester if we need to.
Okay. Yeah. I get a lot of question about like what kind of material we can print, and the fact that the EPIC itself can only print PLA, and that's basically end of the conversation, right? Because PLA, as much as if you look at the strength, it cannot outcompete if you're looking for wood or metal. So it's very, in a way, fragile. So when I say fragile, you can basically break it. So this is something along the way when you're still designing process, we can talk more what kind of material you want to print out. Maybe not print from EPIC itself, or maybe some from other places, or maybe do something very crazy, build your own 3D printing. That's also possible. I'm not saying no, you can't do it. It's just you're gonna be investing a lot of your time, and yeah, we can talk about it later more. All right, thank you.
Yeah, sounds good.
So William, hey man, William. Hello.
Yeah. Sorry, I didn't know if it was this Will or some other Will. I am a junior in electrical engineering. I'm a member of the electric vehicle event infrastructure team, and more technically the RC kart team. And I have some experience in 3D printing, like I have my own 3D printer, but I'd like to more learn about the design side of it.
Oh, you probably know quite some, some technical stuff, how, the 3D printing function, all these stuff. Okay. So I guess so William, so for today's content, it's more of like general and then very fundamental. So I guess if you have more extensive, like detailed question you want to ask, you can ask me later and then we can talk about it. Okay, thank you. So the next one is Yu Ho. Did I pronounce that correctly?
Hi, yeah, no, it's Yu Ho.
Yu Ho, yeah. Okay. Hello.
Hi, how's it going?
Yeah.
So I'm a senior in computer science and under the ISD team. The reason I chose this session to attend is because I'm very interested in 3D printing since it's becoming so prevalent in our modern lives nowadays, and I don't really know anything about it, and that's why I'm here.
Yeah, that's actually a good point you made. Yes, indeed. A decade ago, there's not such thing as a 3D printing concept, and now it's everywhere. So yes, you made a very important point. So do I have everybody? Did I miss anybody? Yes, no, I think I cover everybody, right? Yeah, so if you have any questions, feel free to put it on the meeting chat and then I can see it. So there's no list that you need to be on this meeting anyway. So right now I don't keep track of attendance. So basically I just assume that I believe whatever the team that you're in, the TA basically have sort of announced that you will deliver a report that telling that what kind of skills sessions you'll be participating, and then therefore we just trust that you'll be participating in all these skill sessions. So yeah, okay, so let's get started. So feel free to stop me if you have any question. You can just interrupt me. So all right, so I want to make sure. Can you guys see the slides? All right, I see you guys can see the slides. Okay, so well, one of the thing is, give me a few minutes. Okay. So yeah, so this class is designed for 3D printing and material selections. So I'm gonna go ahead and skip the video. So what this really video is kind of portraying is that technology really advances. A decade ago, there's no 3D printing for material, you don't even have to think about printing metals, but now there is. So why the reason why I'm showing this video is sort of to give you a horizon of thinking what will happen for 3D printing in the next decade, because what you will learn might not be what it's going to be in a decade going on. So it's just sort of relevant to sort of embrace, okay, what's the next technology that's going to hit us, and you don't want to waste your time in like learning something. It's probably going to be not going to be used in 5 years or 6 years or 7 years. So that's an important thing. So yeah, so I think it's like in terms of technology and these terminology and all these like skills and stuff, I know it's very important. You can definitely find all these, I guess, like these technical stuff on a YouTube video, which is that's kind of funny, right? And why am I having this skill session right now here? I think always as engineering, and I believe now, correct me if I'm wrong, and then you can shout at me that I believe all the registered students right now in this class are all engineering students. We don't have any business students taking this class right now, right? Okay, so by the sign of silence, I believe you guys are all engineering students. So the reason you can see those, I'm showing all the prices and the ranking right now. And if it matters to you, it's always to like sort of have an idea, okay, what is the 3D printing right now out there, what's the price? Because at the end, you want to be as successful as a 3D printer or be skillful. You always, at the end, it's all about money. And that's why how you get a job and then how you be a valuable to your customers. That's what I'm pointing at. And if it still doesn't make sense, we can talk later. So I want to kind of show you is that you can see, and I'm gonna pull out I'm going to pull out my pen over here. So you can see the price really fluctuates severely. So you have like a 2,000 and then all the way to the bottom of like a couple few hundreds. And then over here, they sort of the best 3D printing. And then it basically just gives you like the winner original Persia i3. This is the famous one. And then you have different, like it gives you a ranking of all these types. And then if you look at this, again, getting back of 3D printing, different kind of range, and then what is it best for? And then what's kind of area it's printing. So like for the first kind of student, when you're getting into this area of 3D printing, the reason why I kind of show you is that you can see that one of the things that's always sort of very confusing is that what is it best for? And then they put of like product design engineering classroom, and then consumer, and then casual. Over here is a casual experiments over here. It doesn't really ring a bell to you if you want to know, okay, what is at the end, which one you want to choose, right? Like you don't know which one to choose, and a lot of them it really depends. Okay, if like the spec you're printing at, but at the end it's basically when you want to Google and then you want to search like 3D printer, you just find one which one is affordable. So I guess I'm gonna talk about how to choose the right 3D printer and then which one probably might suitable for your project, and I'll probably answer that question along the way. So this is what I'm showing. Hopefully it makes sense. So this is a kind of sarcastic way of saying like, wait, like I'm so confused right now. Like there's basically so many brands like same as car right now, right? You basically have these, Nissans and Toyota, and then you have Bentley, which is a high-end version of 3D printing, and there is. So this over here at the end is like, what's your budget? So I think the way I'm putting it might sound like, yeah, duh, like what's your budget? Like if I have like my $1,000 in my pocket right now, I just might buy the most, the best 3D printer and then solve everything. However, it is not. A lot of time it goes into 3D printing. We have the self-alignment and auto, the quietness and time efficiency. These has to be considered. I think one of the things is what's the dimension of your parts. The reason I put this as a bullet point is that a lot of time when people start printing, it's due to the limit of what they want to print because it's limited by their, the 3D printing platform. Other stuff is it get raised a lot is what material would you like to print, and this is sort of being like a lot of people would like, hey, what's kind of material? And again, I keep talking about is that we only can print POA, but the thing is for the strength of material, POA is actually quite weak. I'll be surprised if you're printing a POA as a material to be, for example, for your bicycle parts or any material that you have to put a force on it. It will easily break. So POA is usually a type of material that's widely used, but it's only for a proof of concept. Now, does odor, like this smells, matter to you? Another reason why if you look at all the printing facilities, they usually POA is the top number one is because when you do printing, it does not give you a smell. If you today happens to choose ABS, for example, or other materials, there might be some smells, and these smells depend. Some of them are it's fine, but some of them can be toxic. So this is something that you need to be aware of. That why the majority of people that they use POA instead. That's one of the reasons to answer like the hazardous thing. Are you planning to modify your 3D printer later on? So I get asked this kind of question a lot. So for example, getting back to this list over here, sorry to kind of jumping back, Prusa i3, and then I have actually this one in my home, the Creality Ender 3 Pro. Now these version of 3D printer, you actually can modify it, meaning that you can manually like switch the nozzles and even they put an inclusion on it. Some of the commercialized packaged one, like for example the Dremel Digit Lab, so you see the price of here like close to like $2,000. Now these of them is a little bit hard to change because it's already come with a commercial package. So same as Automaker 3. I mean, you can change it, but the software that it already given, and then the way that is sort of built up, it's already pretty commercial package already. So it's really limited amount you to do any modification. So that's another checklist you can put it on if you're thinking this on the way that, hey, today you invest on something like a $300, $400, it might print a sloppy 3D printing, but along the way, if you want to do some modification, upgrade to fulfill your spec, that's something you should consider. Hey, why not invest on something that's only a little bit affordable one that you can adjust to your spec and then move along on the way, rather than invest on something like a 2,000, 3,000 3D printing where the spec is pretty the 3D printing stuff is pretty much fixed that you cannot change anything. Okay. So again, I mentioned that EPIC itself right now we have actually three 3D printing that's kind of we have right now. We have the Dremel and Ultimaker 2. Now you can see the dimension itself. So the dimension I listed is again try to sort of bring up the idea that okay, if you want to today print something that's sort of bigger than this dimension, you basically run into a trouble of okay, you basically have to print this device into two parts, right? And then later, once you finish printing, and then connect these two parts together, which is a disadvantage because you will introduce defects inside, and later, cause material to fail. That's one of the huge consequences we need to consider. And another thing is that you can see these two 3D printers, the layer height that I listed. So the follow-up question is that I listed, hey, Dremel and Ultimaker printer, which one has the best resolution? So yeah, so you can see right now over here, you can see this number over here is lower, right? So basically this one, the Ultimaker 2, we can give a rough, just saying that, hey, this might have a better resolution. But again, debatable between okay, how fast you're gonna move the nozzle. That's something that also you should consider. But this is just a quick rough number you're looking at. Okay, if you want to print something that have a more precise dimension of it, this is something you should also consider about the height, right? So yeah, so just to what I mentioned about is it economic to build your 3D printer and why there's so many available brand out there. So I know a lot of people want to know 3D printing and stuff, and the kind of perspective I'm taking into is first look into what is the budget and money, and then a lot of people might be surprised that doesn't make sense. We're engineering students, we want to get our hand dirty, but okay, where's the money? So that's why I think it's important to first kind of look into why do we have so many brands. And then if you start looking into it, then you realize because they actually just want to sort of answer to originally what the question is, is it economic to build your 3D printer? So moving forward is 3D printer, you can build your own 3D printer, and then you can basically find all these stuff online. There's a lot of people that they show how to build a 3D printer. Now the concept of 3D printer basically, if you guys have ever seen CNC, or a gantry, it's basically for sure it's just a XYZ axis, and then you have so I'm doing this very poorly, and so you have an XYZ axis, and then you basically have nozzle that's running this direction, and you can move this direction, and then you also have additional Z direction bottom over here, so you can adjust. So this is really not new. I mean, if you have a laser engraving or any CNC thing, all you have to do is just swap that whatever the drawing bits into a printing device, and there you go. 3D printing has finally come out as it is. So right now I'm showing that, hey, what's the concept of kind of switching back is it economic to build a 3D printer while there's so many brands out there? And then I just want to show you that, hey, if you disagree with all these all brand out there because it doesn't fulfill your specs that what today you want to print, maybe you want to print some metal material, for example, or you want to print some chopped carbon fiber reinforced plastic, and some of them they cannot, and then you decide to print something. I actually did a quick research about it. If you want to build a cheap rough run, you can see it's roughly 600 minimum price. So by making your own 3D printing, I listed some of the advantage of here. So it's able to provide a flexible printing parameters such as temperature control and others. Want to give you a scope is that when we print PLA, typically the temperature is roughly around 220 or 250. And some of these commercialized packaged ones, they don't, you can't, I mean, some of them you can just adjust the temperatures, but a lot of them are fixed. depends on what kind of device you're having at. And it's kind of neat that you could able to, change the temperature. Now, the temperature wise is, I believe, and I might be wrong, is the most important factor controlling the 3D printing, right? So you really need to sort of melt these filaments into you're able to extrude these filaments so that you can print. So that's why temperature really matters. I mean, there's a saying that the higher temperature you can raise, the more material you can extrude. So that's one of the things why these 3D printer right now selling out there. Usually these over here and these over there, usually right now they can only print polymers, because the temperature that you can control typically cannot outpass 500 Celsius, and therefore that limits you to print any metal materials, in which if you're looking at more higher strength, metal is the path you should want to go. So yeah, so freedom of printing other filaments, and then a pathway to print continuous carbon fiber reinforced plastic. So this is, I'm going to mention that a little bit later on. So a lot of people, when they figure out that, hey, at the end POA doesn't work, and then if your 3D printing device, of course, you cannot print any metal materials. How about a carbon fiber reinforced plastic? So I'm just going to tell you that yes, for these CFRP, we just going to say CFRP, these stuff has the same strength of a metal, and it's way lighter. So that's why it's very attractive when aeronautic, like in Boeing industrial people, they choose to print they choose to use CFRP because it's lightweight material and it has the strength of a typical metal like steel and aluminum. So it's very attractive. Now that also may be considered if you build a 3D printer. So yeah. So this is basically like a list of, okay, so how do you want to assemble a 3D printer from day 1 to day 5, and then where you want to buy it, and the prices. And so again, circling around, if you want to build this is the 3D printed devices, is roughly minimum $600, right? And then the question kind of circle back if, all right, if you already have $600, can you just buy something that's $600-ish? So this one, for example, the XYZ Da Vinci. This is something on the table that we can, think about. Okay, so moving on into material properties. So now I constantly mention about printing POA. The strength is not high enough comparable to other material that we're printing, for example, POA. However, interesting thing is, and it actually depends on how you 3D print your material. So what I'm trying to say is that you can see the direction I have listed over here, and these are just we so-called in the material science field a dark bone coupon. And what these dark bone coupon is, once we print it, we do some tensile tests. So if you don't know what a tensile test is basically we pull it on either side. God, this is keep jumping. My apology for that. So this is a coupon. This rectangle stuff is a coupon, and then we pull it on each side. So over here, you can see I listed XYZ and then direction 30, 40. So what I am trying to say is that if you have noticed, if you ever had a chance to walk by a 3D printer, or if you have a 3D printer at home, you'll realize that sometimes it print 45 or 0 degrees and 90. And it actually matters about your final product in terms of its strength. So it actually depends on how the nozzle that it print, actually the final strength of the material actually seviews. There's a differences. So you can see over here, I organize a table over here by printing the different directions. For example, plus 45, minus 45. So you can just look at this. So this is the sample over here. And then you have 0 and 90 over here. That's right over here. And then plus 45, minus 45, 0, 90, and then, the way of direction goes on. Now, I want to show you the strength. So if you have no idea of strength, don't worry about it. So basically, I have a table over here. A figure of view of stress. So if you don't know what stress is, basically force divided by an area, and then strain is basically the elongation of the specimen. So here we have the yield strength. Now, if you're still confused, don't worry about it. Basically, we're just trying to find which number along this table over here, which has the highest number. So whatever the number that's highest basically has the highest strength or highest, resistance to failure. So you can see, you would imagine at first that, printing something, you have the same, because it's the same material, right? Why would the number be different? But here it just basically shows itself the strength over here. It is completely different. Okay, 29, 29, 29, and then there's 32 over here. Okay, not even, I haven't even mentioned failure breaking. So this basically pretty much give us a more like an idea. Okay, failure breaking is basically how, like, just focus on the number. So this is 8.89, right? This is 1.72. So basically, according to this experimental data, it's basically saying, hey, if we adjust the 3D printing nozzle, intentionally printing the direction of plus 45, minus 45, and that's right over here, this over here, these coupon, you will have strain and failure 8.89. Now, if we move on to over here, plus 45, minus 45, upright, the way that it's printed, the number is significantly smaller. So here I want to kind of again bring us back. Yes, to answer if anybody has that question in their mind. Yes, POA, the material that we're using. Yes, the strength is weaker, but also you have to consider how originally the 3D printer, whatever the facility that you submit your STL file, how they're being printed. The way the direction is printed actually matter of how the final performance of the material. But at the end, a lot of time when students in the EPICS, when they submit the STL file, they don't really ask, whatever you get the product, oh, there we go, there's a device over here, and then you go see if it works or not. Yeah, actually I'm in the skill section. Yeah, thank you. So moving forward is carbon fiber reinforced PLA filament. So I do apologize, I'm kind of jumping back and forth, but there's just a lot of information I want to kind of cover. So these are some of the stuff we're doing testing in the EPICS lab right now to sort of bring up more of choice for you guys to kind of choose, like, hey, from POA, is there any alternative options we can do? So we managed to buy some carbon fiber reinforced, and then it's POA filament, and then it's chopped carbon fiber. And over here, it actually provides some information about the strength itself. It's 96 MPa, and then so we actually did some testing. So this is just give you an idea of, okay, so we have POA. So again, this is just the material that we use in the EPIC itself, and by far it's the only choice you can choose right now. And then we compare by carbon fiber, POA. And then surprisingly, if you have an idea of this graph over here, so I'm comparing load, comparing to displacement. And you can see POA, this 1, 2, 3 over here is this 1, 2, 3. And then the CFRP, which is this one over here, is over here, these three numbers. So I'm kind of throwing these questions to those people that already have 3D printer at their home, and they already have some experience. If you can answer this, does it make any sense? This doesn't make any sense. Like if I'm printing CFRP or CFPOA, the strength should be higher, right? Because there's a sort of a nomenclature, like sort of a notion of, hey, if we're printing carbon fiber reinforced plastic, the strength or whatever the load for resistance to fluid, it should be higher than POA. But looking at this number right now, does that answer anything right now? It's lower, right? I don't know if you can see, if you know what I'm talking right now. So again, this also is a consequences of how it is printed. It's 90 degree. And is it true that carbon fiber, when they sort of proclaim that, all right, carbon fiber reinforced plastic, are they putting, carbon fiber inside. Maybe they are not. And this is something we want to find out as currently in the EPICS right now. So 0 degrees. So this is, again, it doesn't matter. What I want to show is how it is printed. So you can see the load dramatically starting to change. So over here, there's a big difference. This is like 600, and then over here is 900, right? Over here, you can see this start to increase, and then this drops. So this is POA, by the way. So it dropped to roughly 800, and then this increased to roughly 800. So it's right now it's basically the same. So again, it's kind of go back to how you print it really matters a lot. So again, by the end of this, sort of skill session, I want to kind of have you take away is that like how the 3D printing, how it is printed actually matters a lot of the final performance of the material. So common problem in 3D printers. So a lot of time is that, hey, the printing is working, but it's not, really, printing anything. So a lot of it's like it's stuck in the nozzle. This is something that happens. So nozzle is too close to the print bed. This would normally happen is if you have sort of those not commercialized packaged 3D printers. So you do have to manually adjust the level with the printing bed over extrusion. So again, these are common feature that happens when you buy, like, for example, Endo 3 Pro or Proja. These are not commercialized packages, so they don't have sensor to detect. So it's very frustrating. Well, it depends. If you're like, if you want to make your hands dirty and stuff, this is a lot of fun. You get to learn. But at the end, if you want to just get this project done, this really is frustrating. And incomplete and messy infill, warping, elephant food, print looks deformed and melt, snapping filament, and getting cracked in all tall projects. So these are common thing that happens, the 10 common thing. And how to sort of solve these issues, again, we can talk about it later. So moving on to material selections. Again, this is just a video, but we're gonna skip that. So here's a general organize of the material selections that we're looking into, and then we have it's sort of categorized into metal and then non-metals over here. In the metals, it has like irons and no irons, and then polymer itself, it has some more set, some more plastic, and over here we have ceramic. Now, here's a quick fun fact. So if someone asks you, hey, we have a metal, polymer, ceramic, and then which is typically has the highest strength or highest resistance to failure? Ceramic. So that's the curve like that. So this is ceramic. I'm put a C over here. And then metal, and also have higher strength. So I'm going to put an M over here. And then polymer usually are very low. So it's like that. Very, very low. So let's put a P. So you can imagine right now, whatever the material that you're printing, POA, which is a polymer, it has a relative low strength. So it's like very low over here. And then if you consider metal and then ceramic, it's very high. Okay, so material selections. These are some of the common material that we have in the EPICS. We have iron, steel, stainless steel, aluminum, copper, and then the list go on. And over here, I listed a figure of Young's modulus plotted in density. And the reason why I would like to show you this is a lot of time when you sort of start designing stuff and then you get into a sort of confused or dilemma, or difficulty of what material you want to choose. And over here, it just gives you an idea. Okay, something that density is about weight, right? So the higher density you have means that it's more heavier, and vice versa. Young's modulus of here I'm listed, just think about its resistance to failure or the strength or the load that you can put on. So the higher Young's modulus you have, the more resistant they can fail. So at the end of the day, for example, right now, if you are designing some toys for a children, for example, you definitely want it to be lightweight material, right? So you want to look material that's this side over here, right? Not on this side. No, right? That's too heavy for children to grasp. And then, okay, so for example, you want this to be more of a high strength. You want, if the children gonna chew on it or something, that's a different scenario. But if you want the children to grip on it but without failing the materials, and you're looking something over here. Now getting back in, you want the children, like the children, if you can sort of chew on it or something like that, then there's something you're looking for down over here, right? So stress strain curve. So these are some of the things that you want to make sure when you're designing. I know some of the I guess like the people in the teams, they also do some FEA analysis and stuff, and then these are some of the number you would consider. So one of the criteria to look into is the yield strength or the yield point. So I draw the line up right over here. So whatever these material you choose, and then when you do some tensile test, whatever test you do, you'll always get a curve like this. You goes up and then you start toning or whatever that happens. There's always a yield point that's gonna show up. Now the yield point, what I really want you guys to take away is the yield point determine when the material can recover or not. So what I guess I'm trying to say is that you don't want to get over this point of view, the yield point. So whatever the material start passing this point, basically the material has plastic deform forever. Meaning forever is that it's about to fail, and about to fail depending on what type of material you have choose. But this is basically when you design a material, you want to be kind of bear that in mind. Okay, this is the line you don't want to cross, because once you pass this line, whatever the material start deforming, and then it will not recover to its original shape, and therefore it is unsafe for your final design. So just carefully look at what the material you select, and then look at the yield point. It has a number, and then you can do some testing, and then to compare, okay, has that number surpassed the yield point? And if it has surpassed, then you have to change the material. And if it has not, you're saved. So so some of the mechanical property, like every engineer should know, and then these are basically all the material property you should sort of bear that in mind. It's very common that, like, I would expect every engineer should know that. So stress strain and strength, stiffness, Young's modulus, hardness, toughness, elasticity, plasticity. And then if you don't know, feel free to drop in my office hours. So toughness. So this is, I'm pulling this out is that I know some of your team, you're designing some impact, and if you don't know what impact is I can't really see from you guys. So like something that's impact, very like dropping or hitting on this, this table over here, that's basically impact. And the terminology of this is toughness. So you can see these graph of here, whatever this cover within this region is basically the material that can absorb the energy from. So the more area you cover, the more, the toughness it has, and the more toughness it has, basically it can absorb whatever the material that impact to the substrate. Okay. So moving forward, be cautious about the material that you're using, what material and how was it made, and is it the right material? So again, how was it made sort of answer to the 3D printing, how the nozzle, do its processing actually, at the end dictate its final, its performances. So me as a material science is what we actually, the strength is looking at its processing, and then by manipulating its processing, its structure change, right? So this is a metal structure, and then its performance actually change. So these are all connected together, and then yeah. So yeah, make sure you wash your hands, and then okay. So I think we still have a few minutes now. Is there any questions? I want to leave like at least like 2 or 3 minutes to kind of bring up to you guys, if you guys have any questions, and we can discuss it. Any questions? Man, you guys are very quiet. That's why like I never really like doing a virtual skill sessions. I don't even know if you guys are there or not. Hello?
I'm still there.
All right. Thank you.
You got at least one.
Huh?
You have at least one, because I'm here.
Okay, you have at least one? Okay, appreciate it. I thank you for the effort, but okay, any questions, any question is fine. You don't have to worry. Like if you ask me what is a 3D printer, I won't be angry, or you guys all fine. Or does someone mention that he also has a 3D printer at his home and they want to get more? I'm really sorry that I didn't give you more extensive knowledge, but we can talk later. I'm gonna still be here.
No, I learned a lot. That was important. I've done a lot of random. Also, your QR code has been disabled for some reason.
Yeah. Actually, so it's for the QR code you can disregard. Right now, I don't think I have to make sure they still submitting the QR code. But I don't think we're reporting any QR code for right now. But thank you for telling. Yeah.
Yeah, we have an Ender 3 Pro in my room right now that we print things with.
Really?
Yeah.
Okay. How's that 3D printing now?
Do you print only with PLA and with your Ender 3, or do you print other materials?
So right now I have a Ender 5 Pro in one of my offices. It's mine. So what originally I was trying to do, actually right now I'm still doing, is to swap the nozzle to print chopped carbon fiber reinforced plastic. So right now I'm also currently trying to build an extruder so we can continue extrude the filament into the Ender Pro 5 Pro. But we're having a lot of issues. But I'm glad if you wanna hop in my office so we can talk. It makes sense.
I'm gonna have to do that sometime.
Okay. Yeah. So someone asked, have I used a 3D printing pens? This is actually interesting. No, I have not heard. Is there actually a 3D printing pen? Is it like a pen and then actually it prints something, or? Yeah, no. Actually, I never heard of it. This might be something new. So, do you have a personal favorite printer to use for rapid prototyping? So, I guess that's actually a good question. So, I want to answer that to, it depends on your budget. If I guess today, like if your budget is sort of around like $300 to like $800, which is typical. And by the way, to buy the most like cheapest 3D printer, I believe like you probably need like at least minimum $300, right, to buy. That's the least I have seen for now. But you don't want to buy those really too cheap ones because in terms of quality, they might be very bad. For example, Ender 3 Probe or Ender 5, that's actually pretty good. Some of the lists that I actually just show on the rankings, like the Creati, let me pull the Persia one, actually is also pretty good. On Amazon, it actually has a ranking list. I think that's also fine. You can just look at whoever who choose that one and then just buy. I think at the end it's a lot of like tuning. It's going to be very frustrating. So yeah. Okay. So I think if you don't have any further questions, I'm just gonna end the sessions, and then feel free to stick along in this channel. I'm gonna be here. So if you're good, go ahead, and then hopefully if you have any questions, just send me an email or join my office. I'll be here around. So thank you.